You're listening to the N2K Space Network.
Space assets and operations are critical to the security and economic well-being of many sovereign states. Commercial space is an increasingly important part of space operations and provides support to other sectors within critical infrastructure. So, space is an inherently harsh environment for operations, and space systems are subjected to cybersecurity threats from their own unique vulnerabilities. As space becomes more important to our critical infrastructure at large, the impact of a cyber attack and the corresponding risk increases. So what does the space cybersecurity threat landscape look like? Welcome to T-Minus Deep Space from N2K Networks. I'm Maria Varmazes. Our guest today is Rebel Space CEO Carrie Hernandez Marshall. Carrie has unique experience in both space systems and cybersecurity, giving her a clear view of space's unique threat landscape and how attacks there continue to evolve. That's why she founded her company, Rebel Space, which blends artificial intelligence, cybersecurity, and radio frequency sensing to safeguard spacecraft, ground stations, and mission operations from complex and ever-changing cyber threats. Here's more from Carrie.
We started the company in late 2019, really just doing a lot of consulting work at first, and then decided to go into full venture-backed corporation world in 2020. My background is a little odd. I started out in the Air Force, U.S. Air Force, as an enlisted person, landed in, they give you a job. The job they gave me was to be a signals intelligence person doing Chinese Mandarin translations. So that was my introduction, to the world of the military. And it was interesting. I spent a lot more time playing with equipment and signals than I did really getting better at Mandarin. I can maybe order in a restaurant. That's it. So
good to know. Next time I'm there, I'll be like, calling you.
When people are talking about me, that's about it. It wasn't really my forte.
Handy skill set, honestly. But yes. Yeah. So you wanted to play more with the equipment. Okay, so I can see where maybe that led to where you're at now. Yeah.
Then I was into tech, and so all right, what do I need to do to do that? So I went, got out of the Air Force, and I went into electrical engineering. Got my electrical engineering degree at the University of Wyoming. Landed back in the military as an officer right after 9/11. So ended up in a strange position being electrical engineer, previous Intel person in the military with no job. So I got sent to Vandenberg Air Force Base. And the thing, they go to this one organization. It was Space and Missile System Center, or Space and Missile Center, Det 9 at the time. And they're like, go talk to all the commanders and see who wants you, see who needs your skill set. So I walked around to each one, like, hey, I'm Carrie. I'm a brand new lieutenant. Here's my background. Here's what I do. And I landed at what became the 4th Space Launch Squadron, working for Lee Rosen at the time, who later went on to do all kinds of crazy things in space launch and at SpaceX. So that
I was going to say, that's a big name. That's, yeah.
So Lee's like, I like you. So brought me in. That core family at that unit just stayed together. Like, we are all intertwined, still working together quite a bit. We all ended up, a lot of us at SpaceX, and now have our own gigs. So that's how I ended up in space. So I did space launch for a while. Then I went and I got into another strange world after that job in the military. I ended up as reservist and also defense contractor working in space electronic warfare. So we were at this organization called the Space Range, where we're responsible for building and figuring out all the ways that space systems could possibly be broken and how we can prevent that from happening before we field systems. So now I'm on this trajectory.
Yes, yeah.
So now I'm learning how to all the ways to protect space systems. So after I did that for a while, built a whole bunch of really cool, space simulations and environments and things that were used to both train Air Force operators for how to do space system operations, and then also kind of just figure out where the gaps were. Which went there into the world of network warfare. So this is where I start to intersect more into cyber world. And so I ran a pen test team and a test and evaluation team for the software that was being deployed in the Air Force side. And so now I'm doing cyber. I'd done space. So, I kind of just lived in these worlds.
You've had like 3 careers already.
I haven't even got started, right?
I know.
But they all go together. They all go together. I'm always the person with and it goes back to the original premise. I'm the person with signals, huh? Let's talk to you. During this whole time, I had been getting, my graduate degree, and I was in a PhD program, kind of early AI, because I really had this obsession with starting way back in grad school about, just time, kind of just unsupervised machine learning. How can you use AI to do things that when you're talking about complex, they call it black magic, right? Communications and wireless and all this stuff. And I'm like, there's got to be a better way. And so I started looking into kind of the beginnings of applying AI to communications and to networks and to the RF environment to kind of figure out that, it can be doing it better than us, right? We can do cognitive radios. We can have these smarter things. But about that time, when I was in my PhD program working and running the network warfare team, I got a call from Lee Rosen, and he's like, hey, do you want to come to SpaceX? At this time, it was 2014. Things weren't, as mature as they are now. Things are still blowing up. And he's like, yeah, can you come to the launch site, run the RF and telemetry communications side of the house? And I'm like, yeah, that sounds like a lot of fun. Rockets are never boring.
That's a great way of putting it.
So then I walk into commercial space land, and I get exposed to both, kind of just this new era of how things are done on space. The go fast, build quick, fail fast mentality. And I go from there into another tech startup, Slingshot Aerospace, for a while when they just get started. Just kind of, I knew them from the military, helping them out on some of the tech development roadmap. And that's where I kind of got the bug for startups. So when I finally decided to do that in 2019, I was like, all right, what do I want to do? What has been what needs fixed? And that's where I got to, hey, you know what? When I was on the defense and the government side, I assumed the commercial had the best stuff, man. I thought they're going to have all the great software. They're going to know everything on. No. So you show up, it's like, no. Cybersecurity, afterthought. Any use of any advanced analytics tools for making sure signals and communications, you understood what was going on. The focus is still, like I said, to get on orbit. And that's not wrong. But, at some point we have to move beyond just, we're happy we got there. We're happy the capability works. Let's pretend now that this is now important critical infrastructure and treat it in a lot of the ways that we treat other critical networks and infrastructure.
Wow. Okay. Your story is awesome. So thank you for walking me through that, because it just speaks so much to how much you have so much experience in both the space and cybersecurity world that you can really see that both landscapes truly. And what I'm always personally fascinated by, as you just sort of touched on, is sort of why have the two not meshed as well as we know that they need to? And we were sort of chatting about this earlier. Is it a cultural thing? What's the deal? But also, I think people who are more mature in this space recognize as you said, there's a lot that needs fixed. We are not there yet. And I just would love to get your thoughts on, my God, where do we even start with this?
Yeah, right. Well, there's a running joke, right? If you put something in space, who's going to mess with it, right? You're not, for one thing, if something goes wrong, you're not sending the IT guy, turn it off and on again, right?
Nick from IT just up there.
Yeah, it's everything has to be done ahead of time, and it has to work. And in the past, we were, the assumption is that it's just too hard, right? It's too hard to touch. It's too hard to get it up there. So it's definitely too much trouble for anybody to mess with it. Beyond, maybe nation state kind of stuff. And in that case, everybody's like, well, I'll just use my insurance, war clause, or, I'm not going to, I'll just take the loss, essentially. And so I think, it's not that, everybody kind of knows, everybody knows that cyber is important, and it's just not a priority because we haven't had that sort of major event to drive us, right? There hasn't been the big hack. There hasn't been the big takedown of something that we really need on a day-to-day basis. And now this keeps the military, the government up at night, enough so that they've funded us, very well. But commercially, it's just, the incentives aren't there, I don't think.
Yeah, and unfortunately, it's one of those things when that big hack does happen, there's going to be a lot of a scramble to catch up. But we really don't want that to happen. We'd like people to be proactive, but, humans are what humans are. Can you give me a bit of a walkthrough of the threat landscape for space? Because this is something that even with my cyber background, it is a different flavor when it comes to space, not just because it's in space. I mean, we're talking about RF signals, and signals very well. So walk me through it.
So, that's just one layer. So we're partnered with the Space ISAC, which was stood up to really provide kind of similar ISACs, like information sharing analysis center, same as energy and power and water and all these other critical infrastructures. And so they would be great if you haven't had them on to come in and talk.
Talking to them next month.
Perfect. Yeah. And they have just this running board of things that are going on. And so, this kind of comes back to rebel space when we're building. The main problem is that it's in space. If you're talking about the communication side or even the system side, troubleshooting, like anomalies, determining what is an actual problem and a threat, and what is it it's me, right? It's like, and I think that's true in a lot of complex physical systems, but specifically in space, because you have to to identify something specifically as somebody is messing with me. I've been deliberately interfered with. Somebody has deliberately sent a command. I mean, those are seen. Like, people do try all the time to take over satellites. Like, they try to send commands and see what happens from all sorts of players, because it's fun. It's in space, right? It's like the ultimate hack, right?
I pwned a satellite. Woohoo! Yeah.
Right. I got in and got access. But it's still hard, right? And so what we see is a lot of stuff that is just getting, we don't either don't catch it, or we just kind of say, all right, I don't know. If you take a hit in your operations, but then it comes back, how much does it matter? So the problem there is that, I think as we mature and as things become much more juicier targets, right? When it becomes, really interesting to try to, mess with a Starlink, or, try to take down, some critical piece of a constellation, it's going to escalate. And if you don't catch things early, if you can't differentiate between something that is just an anomaly in the environment or something that's something on your system, it's just hard. It's just hard to even begin to unravel that, because again, we don't have access to these physical devices like we do in a physical network, right? So when something goes wrong in a physical network and you don't know and you're trying to troubleshoot, what do? You go plug it, you swap it out, and that's not an option.
We'll be right back after this quick break.
And now, a message from Cyberbit. Mastering cybersecurity is like mastering a sport. You build muscle memory through rigorous practice, then you train as a team to foster cohesion while operating under pressure. Like athletes, cybersecurity professionals thrive on hands-on simulation. But traditional courses, certifications, and open-source labs won't build you a winning team. You need Cyberbit. Cyberbit offers a hyper-realistic simulation environment for your SOC, IR, and C-suite to refine your skills, all using the market-leading SIMs, EDRs, firewalls, and WAFs they use every day. Cyberbit is offering CyberWire listeners a free live-fire exercise. Sign up your team now at cyberbit.com/cyberwire. And now a word from our sponsor, Netskope. Netskope is a worldwide leader in SASE and Zero Trust. Its unified platform, Netskope One, provides optimized access and Zero Trust security for people, devices, and data anywhere they go, helping customers reduce risk, accelerate performance, and get unrivaled visibility into any cloud, web, and private application activity. To learn more about how Netskope helps customers be ready for anything on their SASE journey, visit netskope.com.
I was wondering, as you were talking me through this, attribution's tricky on a good day. This is a sort of a flippant question, admittedly. If your satellite is being messed with, does attribution really matter if in that moment? Or is long-term, I imagine you want to know. But in that moment, you're kind of like, I just need to get this thing non-messed with.
Attribution, it's always hard. And, ideally, yeah, it'd be great. And attribution in a way too, like, it's just even when it's innocent, like if I have interference, if I know who's doing it, I can tell them to turn it off, right? And every time I fly over this ground station, something happens. All right. If I can pinpoint that, and you can sometimes, right? You can figure it out. But the more important question is, what happens next? So if I'm seeing this pattern of things and it's not me, and I can know that it's not me, it's not my system, then I can also say, one, I can avoid it, take mitigation measures, just standard risk management practice, or, the other thing I could do is I can just be responsive to it and understand that, like, okay, I see that this has happened. And in this pattern I've seen before, and say in our community, other people have reported that the next thing that happens is this. So, maybe it's somebody just trying to see if they can spoof my signal. They can pretend to be something they're not, trying to trick my satellite to think they're the ground station. This understanding that attribution aside, but understanding that pattern.
Yeah. Like, is it an accidental interference, or is it malicious? Or is it, one masking as the other potentially? This is the part where I get really fascinated by how this all works, because accidental stuff will happen, but, I imagine it would be, now I'm just making stuff up now. I'm imagining it would be really fun to pretend. Anyway, I'm gonna leave that thread off to the side. Anyway, so
and another piece too, part of that, just real quick, is that there's a supply chain piece too, and interesting enough, again, these are hard problems. We're trying to fly things in space and all these crazy physics that we have to deal with up there. And if somebody has put something in your system that you're unaware of, right? If there's some small piece of code or something built in, because you are trying to lean forward and do these really hard things in space, it's hard to tell sometimes if that's just your design. Did something go in there that is actually going to affect you? And so understanding and having that pattern analysis of what normal should look like for this particular satellite is really important, because now you flag internally also things are, okay, that's weird. I got a weird command, it got rejected. Now suddenly this particular subsystem on my satellite's acting funny.
Do we have the technical capability, maybe at large, to understand what threats are going on at what time? Like, do we have that visibility at this point, or is it still kind of bits and pieces?
I would say people, like in every industry, if they know that they're seeing patterns, they're not reporting them because it shows, it's not something people like to admit, I think.
No, yeah, that's true. Yeah.
And so, and again, I think a lot of times satellite operators or some of these more ambitious space systems, if you're seeing stuff, one, you're not maybe 100% confident if it's you and your system, or if it's something external. If something happened that was, a major interruption or something, you're not reporting it out because, space market is already in kind of this precarious position where it's supposed to be the, grow and be giant and all those commercial markets. So you're not advertising if you can't pinpoint why when something's happened.
Yeah, makes sense. So, we've covered a bit of, what the current threat landscape looks like, and there's a lot of different things that can happen. Some more, terrestrial, pedestrian threats, I suppose, like, doing even Viasat when it had its issues in 2022. It was a VPN. I think it was like a VPN issue, essentially. Or I may be misremembering that detail. I apologize, but it wasn't like a super sophisticated hack. It was pretty much like something wasn't updated that should have been. And that's kind of like, it keeps a lot of people employed in the cybersecurity industry. Is that kind of thing? It's like, all right, we've seen this before.
That is true.
Yeah. When we think about the future of cybersecurity in space, and you sort of hinted at it, we're getting these incredibly sophisticated constellations that are being built at a breakneck pace right now, and going in or already are in space right now. I mean, what does that mean for what we're looking forward? What kind of new threats do we think might be emerging there?
I think what's kind of hot right now, hot topic that we are also, looking at how to address is the use of autonomous systems and AI on the space systems themselves. Kind of a joke, AI for AI. But we're going to rely on more autonomy, right? Because, again, we don't have that. We're not flying these things or so much. And so on orbit, especially if you're doing crazy stuff like cislunar, on orbit, you need to be able to have these smarter machines that make smarter decisions, and you can reconfigure and if they see something go wrong, adjust. One of our key things right now with Space Force is we're supporting the orbital prime program, which is in space assembly manufacturing. On orbit, vehicle to vehicle, type of action that really can't be done manually. That's really hard to build in the perfect non-machine learning, non-autonomous system. So how do you know when those are getting poisoned? How do you know when your data's off, either intentionally or unintentionally? and how do you understand when to kind of throw a stop on that? And so, I think we see this in the autonomous driving cars now, right? All the deep safety concerns about how do you check the AI, how do you do safety and resiliency? We need that same thing on orbit, especially if we're doing more ambitious things where vehicles are approaching other vehicles and, trying to maintenance and service them. Because you don't want to. What happens if two cars crash? It's tragedy and people could get hurt. But if two major space systems crash in orbit, that trash is in orbit.
Yeah, and definitely we don't want the Kessler effect happening that would be an absolute nightmare of. My goodness, yeah,
right. So even just somebody messing with it, even like just say not the super sophisticated hacker. Let's just say somebody's aware that something's going on. They might try, maybe I try to jam something. Maybe I try to see if I can spoof a command. Maybe the AI on there just, has a bad day. I don't know. So we just need to be thinking, I think, like this about how we go forward and protect and, from all different kinds of things.
I'm going to ask a philosophical question because I feel like you're the perfect person to answer. What do we need to do? Those of us who are sort of advocating for better cybersecurity within the space industry, especially on the commercial side, what do we need to do to sort of communicate better or get through to folks that sort of know but don't put it as a priority? Like, you need to move this up the priority queue. How do we do that?
Yeah, that is a hard question. I think there's a couple of key things. I think, treating space as critical infrastructure and having it designated in that way is important. Because then it does officially kind of stamp it as like, hey, this is just as important for us as our power systems, as our public utilities, all these things, right? We're reliant on it. It has an impact. I know that's more regulatory or, administrative, but I think that's important because it's an acknowledgement that if you're operating up there, it's no longer the Wild West. We have to have some sort of guidance, like some rules on this. Yeah, I think that's one of the more important things. I think from my perspective, from adoption and it's kind of the same thing that happened, I think, with Splunk, from what I've heard, where they went in with security. We're going to tell you everything going on with your system with observability. But at the end of the day, it was the more, can I make and optimize my network operations? Can I understand what's going on so I can troubleshoot better? And I think that going forward, at least from our perspective at Rebel Space, is that, let me help you understand your system better. Let me give you all the data, on these, non-IT, non-IP kind of networks. Let me give you that deep physical analysis and ability to detect anomalies. So now when we get to that point where, we have a lot more cyber attacks going on that we know are happening, I can immediately resolve and tell the difference, and I can mitigate that risk.
Yeah, not just throwing data at people and logs at people and go find it. It's we found it for you. We're letting you know. We're not making you figure it out. Yeah. Exactly.
So really, it's just the value prop, right? If I can help you optimize your operations and go faster and do better, understand more of what's going on in your analysis and in your system itself, then that naturally can feed better into a cyber solution. And I think we see that in mobile network deployment. It's we're less worried about maybe people immediately trying to hack a mobile network, but we are really concerned with optimizing the use of spectrum and, what's quality of service and these aspects of it, which again lead into better security posture.
Carrie, this has been a fascinating conversation for me personally. Thank you so much. I wanted to make sure I gave you the last word. I always like to make sure my guests have the last word if I missed anything. So this is sort of the open opportunity. If there's something I missed or something you wanted to mention, I please go right ahead.
I think my takeaway is just, having been in both industries, my key point, I know I've said this several times, is it's just, we need better tools. We need better software tools. And I know it's hard in the space industry right now because we don't have the same sort of commonality of software that is used, in other applications, right? Like everybody's not just going to their OS and it's not Linux or, whatever. And it's not Cisco. We're not just off the shelf things. Everything's a little bit artisanal, a little boutique still.
A lot of homegrown. Yes, exactly. Yep.
A lot of older hardware solutions because they're flight proven. And so, I think it's really important that if that is going to be the world we live in for quite a while, then we need to at least invest in kind of a common understanding of what is going on with our systems, what is going on with our software, just so that we can even begin to be prepared for a future where there are legitimate and major attacks going on.
That's it for T-Minus Deep Space, brought to you by N2K Cyberwire. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. T-Minus Deep Space is produced by Alice Carruth. Our associate producer is Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karp. Simone Petrella is our president. Peter Kilpie is our publisher. And I'm your host, Maria Varmazes. Thanks for listening. We'll see you next time.
Hey listeners, we're always looking for ways to improve the N2K Cyberwire network and maintain the intelligence-driven news experience that keeps you in the know on the latest developments in cybersecurity. We've launched our 2024 audience survey and would love for you to take a few minutes to share your feedback. And hey, there's even a chance to win a $100 Amazon gift card if you complete the survey. Visit cyberwire.com/survey. That's cyberwire.com/survey and share your feedback now. And now, a word from our sponsor, 6sense. 6sense provides award-winning cloud-based automated endpoint and vulnerability management solutions to streamline IT and security operations. With its advanced platform, businesses gain complete visibility and control over their infrastructure, reducing IT and security risks and optimizing operational efficiency. With 6sense, you'll get real-time alerts, risk-based vulnerability prioritization and remediations, and an intuitive automation and orchestration engine so you can focus on your core business goals, confident in the knowledge that your enterprise is secure, compliant, and running smoothly. To learn why enterprises choose 6sense, visit 6sense.com.